Welcome back to our Scala class, and today we will finish our NIM game. We will add multiplayer option, meaning playing multiple games so we don't have to stop after a single game, and also improve the computer AI, or maybe add different levels perhaps. And if time allowing, also we will clean up maybe a little bit database operations, maybe add some more migration functions. Again, so let's go to our data.NET6. Actually, I'll be working with data.NET6, but I'll add a simple, maybe I'll add a project here. Let's see, where's our project, right? Where's our project here, right? Source, main, and I'll do data.NET30, right? Scala class, object. We don't really need it here, but I'll just solve for 30, clean, improving name, right? Improving game, right? So. Again, I'll just put to-dos. Basically, we want multiple games to do multiple games, possibly multiple changing players, right? Multiple computer levels, perhaps, right? That'd be nice. And again, time allowing, also possibly to do maybe add some database. View migration, right? Because possibly that's again time allowing, right? Okay, so that's our attack plan, right? Extends up. We are not really gonna run it probably, but so let's move on to go to our data.NET6, right? That's actually where app is. Of course, you wouldn't call your app data.NET6, but you call it actually whatever your game is looks like. And again, of course, I should reiterate that this doesn't have to be a game, right? It could be something else, right? I mean, the structure, it's pretty flexible. It doesn't have to be a game. It could be a business application, maybe adding some items on your to-do list, for example, right? Okay, so we want to have multiple games, right? So how would we do it? We have a game. So our game loop is this, right? So while game is active, then we have a cleanup, right? And we have a bunch of things we do. We save on CSV, we save to database, right? We update the database, and then that's it. Then we quit, right? We print all players and we quit. So the natural place to ask would be here. Do you want to play another game with same settings, right? Yes. So we could ask here, right? Basically, we could use the flag. Next game, right? Next game, right? Next game prompt, right? Or input, maybe. Do you want to read line, right? Read line. Do you want to play? Do you want to play another game? Yes. No. Right. With exact same with same players. And this will be start for now, right? Yes. No. Yes, no, yes, no, right? And of course, we'll assume or yes or enter. We could just enter basically, right? And then we could quit basically, right? And that will be our input, right? It will be a string. We'll have to basically read it, right? And basically, then it will be going to loop, right? And for now, we'll just use this, right? And so we'll use a game loop. Do we need another game? Is new game needed? Right. So we'll set it up here. Right. So we'll basically we'll move these two functions right up and set up here. Right. We need to have this set up. So let's do this. Right. I'll move these. Right. So I'll move these up. So Control X, right, and I'll move them up here, probably somewhere here, right, for now, right, and we'll do a setup here, right, again, so let's move it out maybe here for now, Control Z, let's do it here, yeah, we'll do it here, right, yeah, okay, looks good, and let's do a variable, right, let's do a variable. Basically var, right, is new game needed, something like this, right? Is new game needed? It will be true, right? This will be, of course, something which will keep changing, right? And basically right? We'll do this basically. While is new game needed, right? We'll make a loop, right? And that's where we're gonna put everything else. And let's see if we need everything else in here. Okay, so we need to set up this value. And let's see, will we introduce scoping issues? Because it's a value, it's good, right? We could of course put it directly here, right? Is the A player starting? Let's leave it in here, okay? And so A starts first, and the rest will be actually all of this stuff here, right? So we can clean up all of the all of this show status. We can clean it up here. Let's do this here. Control Z. Right, we don't need any of these comments. All right. Again, we'll probably have to clean this also up, right? So we have a lot of things we want to do here, but so we will do this, right? So that looks like everything, right? So, right, so we'll have an object. We already done this, right? So we already made an object, right? So we already have made an object, right? Right, and it looks like everything is ready to move into, right? So we assume we always want to have one game, and Control X, right? Here is the big, here goes nothing, right? Control V, right? And there we go, right? Of course. So now, of course, we could skip the value, and so basically, if next game input starts with lower, well, let's do lower to lowercase, right? To lowercase, just in case. So people who enter yes something to lowercase, right? And starts with y, right? And can we do yes? We can do this, right? Starts with y. Let's see. Does this take yes a string prefix? Okay, so we check if this starts with y to lowercase, right? Gives you a so all characters to lowercase, rules of localization, and then what we do? Well, basically we create is new game needed equals true, right? Right? Else, of course, is new game needed false, right? Again, pretty simple, right? Of course, you could do this. You could optimize this in the one. You don't have to do both, right? You could do the same thing, read line, and do it immediately. But again, I made it in two values again, just to maybe a little bit more clear. And that should make us. We can play forever, right? Thank you for playing. You know, come again. Thank you for playing. Hope to see you again. Right. So, right, we'll do a smiley, right? All right. So that should, well, I'll leave it to do for now. Let's see if this works, right? So we put everything. Again, all the methods we don't have to, of course, we don't declare them. We don't have to declare, but and let's see what's happening here. There's a problem here, I think. See, I know what the problem is. Name game, right? So there is a problem here, right? This is actually a problem. We don't have access to the name game object, actually, right? So what is my suggestion? How do we fix this? Okay, since inside our name object on the name database, they have the data, right? This is for the game data, and this is for the saving data, persistence data. But here, well, I suggest is we use a functional style, right? We'll pass the object, right? So this needs to be solved. So what's the problem? Problem is that we are creating new game object inside the loop, but scoping, right? This is only available inside this game loop. An outside method doesn't have this name game object. So what could we do? Well, of course, we could make this method also create inside here, right? That's a possibility, and I could show you if that works. Would that fix this problem? But it's not. I don't think it's. I don't like putting functions too much inside the game loop, but it's possible. It's possible right here, right? It should work. Yeah, it does actually work. So it would work. We can test it, right? We could test it. So this function. This function is only inside the outer game, multiple game loop. Only inside the outer loop, right? So it's not available. It's not available here. So if I write something, get human move here, right? It won't work, right? Get human move, right? You see only computer moves available. So that's I don't like putting it here, but let's check if this works, right? So what's happening here? Since we have an in game, right? This references, right? It needs has to find it. It needs to find this logic. So this is now slightly, I think, going off slightly not well. The design is getting a little bit more messy, right? But let's test it first. Again, make it work, make it right, and make it fast. Well, it's always Scala is pretty fast already, but let's see if it works now. Let's run our game, and again, I'll keep beating up the computer since I love beating the computer. And also I could make, of course, val, of course, I'll make val, right? And computer, I'll 3, 3, 3, 2, 1, and I beat the computer. Okay, look at this. Val has 4 wins. Val, this has 3 wins. Computer is doing pretty bad. So, do I want to play with another game with the same players? Yes, sure I do, my friend. Right? I do want to do it. All right. Let's go again, right? It's Val's turn. So I'll do 2, knight to win game, 3, 3, 3, again 1, and I win again. Look at this. I'm getting better. 5 wins, no losses. Perfect score. Computer gets divorced. Okay, one more. Yeah, all right. Let's do one more, right? And I'll do 2, 2. Let's break this 2, 2, 3, and I win again. Why? Because the computer was stupid and it took two matches. Because nope, sorry, I'm not gonna play. Right, again. So of course I could enter, right? Enter would work too. Yeah, right. So our database was updated, right? Well, let's check. We can check our database, see if everything worked. Let's see our scores, right? We have our winners, losers, our database, right? Our scores, results. Right, this was today, right? 5:17. Yes. Well, the timing again. This is Greenwich time, UK time. But yeah, looks like we had some games. Winner 6, loser 4. Right. And do we have scores? Oh, this is going to be a huge table. Look at this. Right. We have a big table now. Right. We keep adding games. Right. Again. That's a good alternative to. I think this is, that's how you do it, right? Because otherwise you have to, what we are doing with CSV at the same time, right? We are doing resources name, right? Look at this game scores, right? Each game has its own score. I mean, again, that's perfectly normal with CSVs, but for database, you don't want to create new database each time you have a new game, right? Each new table. That would be pretty silly. Okay, so everything works. I'll commit. So working version data working version of multiplayer. Well, this is multiplayer working version of name with multiple game support. And now we can just polish it as much as we want, right? Commit and push. Okay, I didn't select any files. So what I want to select is, of course, name, right? And what do we have in resources? Name database. Well, we can update. Yeah, sure not. Well, it's not really necessary, of course, but because you can just have a blank database, right? But okay, so I'll support it. And of course, there's some warnings. Let's see, what are the warnings? Let's check the warnings just in case. Okay, right. So accessor method. Right, it's just saying, right, it looks like accessor, you maybe don't even need the parameters, like but thing is, we might want to expand this, that's why I left it in, we'll probably expand this method. So how about this one, get human move, right, so this one also, so we will want to move these, but I'll commit anyways for now, right, so these are things we would like to probably fix somehow. Again, if you submit it like this, something, it will be fine, but I will show you how we could move this outside, right. So idea is don't have it coupled so closely to this internal model, but we'll have the human, the internal model, right? We want to basically, when we get a move, let's see here, right? Needs integer, right? Move input to. So where is it? Right. We need this access. So why do we need this, right? So well, technically, we don't need anything, right? So what could we do here, right? We could basically, when we call this name method, we basically need this. That's the only thing we really need, right? That's only for customization, right? We don't even need the full object. I mean, so question is, do we have a reference to the object, or do we really need anything else? For the human move, I say we don't really need, this is just for just a little greeting. That's all it really is, right? We don't use any other logic here. Name game, nothing, right? Because, hell, we're asking, do you want to move? And we just need the name, right? The human name. So that's really, there's no point of putting it here. Let's put it, make it more general, right, in our inputs. So again, I'll minimize it and I'll copy, right? So a Control X, and again, I'll put it here, right? For now, right? So now we have a problem, like I said, and we are going to solve it, right? So basically, I say this current player, right? I'd say do this. This is simplest enough, right? Current player string, right? String, right? And basically, a current player, right? Right? You don't even need the brackets, right? Don't need the brackets, right? Looks good. The function looks good. Problem is, of course, now we need to use it here. So we have a, well, get human move, name, game, current player, right? That's it. Simple. A little refactoring, but lets you have a more flexible. Again, for human, we don't want to really couple the name game object to this human input. I mean, possibly we want to get human input from some other object, right? So it's so this is we move this, get human move. I'll move this to method, right? This is a method, right? Right. So again, this input, right, could be used as a utility. Basically, just human move, right? You have a loop inside, right? How to do this? How many matches you want to take? You can maybe ask for something else, right? You could use this as a for some other input, right? You have a nice way of handling this, right? We are catching exceptions, right? Remember this, we let people enter something, right? And we can do this. We can process computer input. I mean human input. Okay, so let's refactor. So let's first check, of course, before I commit. Let's run it, right? So let's run it again. And we have source. We have new change. Okay, that's fine. Let's run it. Deal. It should work, right? I'll do. Okay, let's time for Valdis to beat computer now. 1, 2, 3, 3, 3, 1, and I beat computer. Okay, I'm moving up 4 losses, 4 wins, 2 losses. Computer. Okay, one more, sure. Yeah, why not? Why not? Yeah, all right. And again. All right. Oh, did I lose? After no, I win. All right. So I beat computer. Okay. So nope. No. Sorry. All right. Right. Everything works. And now we can refactor. We can commit this refactoring. Right. Day 30. Refactored. Get human move. Right. Commit and push. And this will be a good, nice, simple, nice commit message. You did one thing, refactor, get human move, you commit immediately, right? Atomic, meaning it's you did one thing, basically. That would be a good commit, actually. I've been, of course, relatively doing these big commits, right? If you do one, okay, and of course I didn't select the file, right? I'm not going to submit the database here, right? I'm just going to submit the date 26. All right, so, right, one farming, what's going on? Right, so that's our AI. That's our next step. All right. So we could of course clean up plenty of stuff to clean up. So multiple games is committed, right? So we could of course also add. Do we want new players? Right. We could do this, right? We could. This is new game, right? We could add more here. This is probably what I will want to add for you, right? To do add support for new player names, right? Right. That's something to do, possibly for you, right? Already. We'll see if we'll get to that. So maybe you want to basically add some if, maybe change this flag. Maybe move it a little bit later. Add another input, basically, right? Check, ask, do you want other names? And then you would basically input you move these two pieces right inside the name, maybe var. We can make this var, probably make this game also var, right? That's the easiest, probably, right? Probably make it var and then make it add new games, basically, right? So that's probably would be a good one second here. Alright, so let's continue our Scala class. We just added our multiplayer support. It would be nice to add support for new player names. That'd be really nice. But let's improve our computers, right? And let's do this. Let's add a computer level, right? Maybe we have multiple computers, right? We have let's add a random player, right? That's a crazy computer, right? Well, so we have a get computer move, right? We would probably want to have a maybe make an AI, right? Maybe, right? So we would store different computer levels, right? And we would also probably give it we keep it maybe separate file. Let's do the separate one. Let's do it in here. All right, in the let me see. We are here, right? So we'll make a new Scala class. We'll make it well, it could be an object, right? Because a class, unless you make multiple AI objects, I'll just make a singleton here, nim AI. I'll call it nim AI. Nim AI. Maybe question is it big letter? I think I'll use this, right? Nim AI, right? And it will store all the methods, right? So I don't have to keep them here. I mean, of course I could keep them inside this date26, it'd be fine, but I think I'll separate out because it's easily moves the computer logic will move outside the this class. And also the thing is we don't have much information. We need to pass some state information. That's the only thing that's important. We'll need to pass some state information, right? So add, I'm not going to extend app because it's not going to be a standalone app. It's just going to be a singleton object, right? For holding, so a singleton object for holding information for about methods for this computer move. So I'll move it first. Let's refactor. So this will be our first try, right? So right, we'll move it here, right? And that's good start, but so that means here we have broken, right? So we broke here. So what do you do? It's easy. Basically, our first refactoring is AI. So again, yes, hard to say. Nim AI is probably two-letter abbreviation. Maybe it should be AI, right? Artificial intelligence, right? But it's also an abbreviation. But so I guess I'll stick with, we use NimDB here, so I'll stick with AI. I'll try to be consistent, right? So get computer move. Okay, but that would be fine. But we want also have a computer levels, right? We have computer levels, right? So let's add a computer level state. So where will the state live? Good question. So I guess we'll leave it inside our main game loop, inside our main application. That, again, date26, right? Application. We could add a computer level, right? So to do more computer levels, right? If let's do this. If we'll do var computer level, right? Level equals 0. Right, on a very stupid computer, right? Bad computer, maybe 1, right? So if player B equals computer, right? You know, then we ask for what level, you know, enter computer level, or we could get an integer, right? Get human integer, right? So we could actually use this, by the way, right? All right, and unfortunately, see, this is nice. Okay, so I like this. I like this move. Everything we want an integer, right? So, right. So what we could do is let's do this. I'll refactor this. I don't want to write this whole thing again, right? I don't want to write this code get human integer. So we could need an integer. We can use this get human move, right? We can get human input, right? Get integer input, right? Again, we'll refactor it. First, I'm going to refactor it to refactor. Get integer input, right? Right. So code should run. No red, nothing red. That's good. So what I'll do is prompt, right? Prompt current player, and we can actually even we can move into this prompt, right? So read line, right? And I could actually move it into even safer, right? So current player. I don't even need player, so I just basically say prompt, right? Prompt equals string, right? And basically, right? And then basically this is going to be a prompt, right? Prompt, right? And now maybe we need an integer. Please enter an integer. I'll use this for now. Please enter an integer. So this is more right? And basically, right? I'll maybe like this. So this is by default. So we will use that, right? So if players be computer, we could have a prompt, right? And we could of course have a change it like so. Computer level, right? Equals well, not var of course, right? Computer level equals what? Get integer input. Get integer input, and we'll use it to get the human input, right? So let's use something. Please enter computer level. Please enter computer level. 1 to 5, right? And maybe something like this. And we actually could use a clamp, right? Do we have a clamp here? We don't have a clamp here, right? Right? Because this is the clamping happens later, right? So computer level. We could do also checking here. We could add the clamps too, right? I mean, again, we can get really fancy here. We can again, that's a good question. Where do we want this extra? Okay, get integer input is nice. We could add some extra checks here, right? We could do the clamping here as well, right? For now, this is we're not checking the computer level, right? So computer level, right? But we can leave this also logic for the AI to decide. If we make a mistake, we'll decide the computer is really stupid and we'll use 0, for example, right? So okay, computer level is getting the input, right? And now, how about this part here? So get human input, right? Where is the game? If get integer input, right? This is good, but this won't work, right? So this is where we need to please enter. So we'll do this, right? Please enter an integer 1 to 3. Enter how many matches you take, and do this maybe S, right? Something like this. All right. Please enter how many matches you are taking. Something like this, right? 1 to 3, right? And okay. So prompt, right? And we have mistake. Nim game, of course. Nim game, nim ID, nim game. Yeah, okay. Everything's good, right? So we made this more generic, right? Please enter an integer, right? We could also have made, if you always get tired of writing this, we could also made another helper function based on this get integer input, right? So now it's it's useful because as our needs grow, right? We need to basically, we don't have to worry about. We can utilize multiple functions. So again, if player B is computer, right? We get the computer level is a get integer level. Okay, so now we have state. We have next time you have a new state which is computer level, right? And let's use that for our AI, right? So we are going to modify our nim AI move. So current state, current current state, right? Here state is in integer, right? On computer level, right? And again integer, and I'll do maybe computer level integer, and it will be, I'll do 0 by default, right? The really bad one, right? So and now we are actually going to current state is good, right? Computer level, we are going to do if statements, right? So we are going to, we're not using these right now, so we are need to have a if case statement, right? We need a Scala case statement, right, to actually separate, right? So we get we'll need different logic, right? So this is not good. This is going to be basic. Get computer basic, or again level 1. I mean, again, since these are separate, get basic strategy, right? Again, current state, right? Current matches, matches, right? Tokens, all right? Current tokens, current tokens, maybe, right? Integer, right? Again, or matches, current matches. Again, one only thing I don't like matches is because matches seem like it's a game, right? So current tokens, for example. But again, I'll call it current state, for example. Current state is an integer. It could be, again, of course, in more complex, right? In more complex games, applications, current state would be some state object, such as nim game, right? Nim game, right? Such as nim, which is nim object, right? Yeah, right. But here for now it's good, right? I mean, I could store it, right, for the nim game. I mean, also that's a good question now. Perhaps we can refactor it afterwards, right? For now, right, current state, and this is of course the current strategy, right? Current state. We don't even need we can even don't need current, get very basic strategy, right? We can do this, right? Int always return 2, right? Always return, or return 1, right? Always return 1. Get minimal strategy, right? Get minimal strategy. We don't even care, right? So this is a really uncaring strategy, right? We don't care about the get random. So I can always think get random strategy. Again, integer will be. Do we have clamp? I forgot the utility. Do we have clamp? Yeah, we had clamp. Oh, we don't have my clamp. My utilities. Oh, what happened to my clamp? I used to have clamp here. Let's check. We'll find it. Right. We'll do math random. Right. It was random next integer. Right. What was it? Next integer? Next integer. Let's say, was it, I think 3 and plus 1, right? Next integer plus 1, right? So because let's read documentation, right? 0 and exclusive. Okay, so yes, we need plus 1. So next int returns 0 to 2, right? So okay, so we need 1 to 2. So we need 1 to 3, right? Okay, right? So hopefully that explains that. So we have 2 strategies already. We'll add maybe more. Add more strategies. Add more strategies, right? right. So random, right? And so 1 is really simple. Random, I think, is better, right? But again, not necessarily, right? And we'll need something really smart. So define. Well, this is actually like, for example, define smart. Get smart strategy, right? Get that strategy. Okay. And this will need current state, right? Current state, right? Integer, right? This will need that, right? And this, of course, now integer. This will need, of course, for now 1. Fix me, right? Fix me. This will be something you will probably want to do. Okay, so we have 3 levels: minimal, random, and smart strategy, right? And let's try this, right? Let's try this. And or maybe we'll get also ultra smart strategy for now. Okay, so how do we choose? We choose on a computer level, right? So this gets an integer, right? So we need to fix this. So we are going to get rid of this, right? So we're going to do a case statement, right? Case, switch case statement, right? And basically we want to have a, right? So match, right? So computer, let's see, current computer level, right? Right? Match, remember our match, right? And right, and then we see case, right? So case 1, right? What do we do? Right? We return get minimal strategy, right? Okay, that's easy. Case 2, we'll do get random strategy, right? Easy. On case 3, we get smart strategy, right? And this of course needs the well, current state. We can't skip it, right? It's current state. Okay, so okay, that works. And now of course let's at least remember case this, right? We can basically we get something, well, we could say this is, we could add an error message here, we could do something, but we need to input something for we could do get minimal strategy perhaps, or maybe we could print an error message, say not allow this, right? We could even quit on you know, or get the question is now, do we want anything? We don't want to break the game, so if something for some reason we could you know, I'll do get minimal strategy for now, right? But could add error message or clamping for levels, right? Earlier, right? So this shouldn't really happen. So this should probably, we don't really in an application we do not want to print error messages, but we could add logging, right? Or perhaps some notification. So this shouldn't. No, this is, you probably don't want to allow this, right? You want to probably clamp this earlier, right? You want to clamp this earlier. So to do, so you would want to check and clamp allowed values earlier, right? Again, it depends what you, right? So for now we are, it's not going to break the game, but it's going to make harder to maybe debug, because if what happens if you have or get a crazy strategy, maybe you could basically you probably again you have to decide whether this is normal. Is it okay to, if you have unknown computer level, right, just get a minimal strategy? Is that okay or not, right? Of course you have to talk with your stakeholders, your colleagues, right, whoever is in charge of this project, right, to see, okay, is this okay, or do you actually want to actually bother the user? Maybe there's an error, right? So, but probably the best thing to do is to check this earlier, right? And so clamp it earlier, right? So we'll do that after in a moment. So let's see our time, right? We have time, right? Now let's see. So we have our strategies, right? So we could get more, fix me. This will be your probably exercise, and let's check, right? Let's check our program. We have our NIM AI, and are we using it? We are using it here, right? Where's the computer used? Okay. So what do we give to this? So we give two values, right? So the move is, if it's current player computer, we get the computer move, and what do we have to pass? Let's check. If in case you forget, what do we have to give this? Come on. Right, so current state will be, of course, NIM game current state, and well, we have computer level, right? Computer level. Okay, that works, right? And we could add, of course, a smart computer, right? We could have some logging, right? So we got right. So looks okay, right? You can remove. Again, so these are internal. These are basically, you can think of these are private methods. I mean, of course, you can access them directly, but so again, current state. Of course, this has to be some sort of logic here, right? So this will be something for you to decide, right? You can use case, right? You can think of something here, right? So get smart strategy, right? Right. Okay. So that will be something for you to start. Okay, it works already, but of course it's not really good, right? Fix me. This is not good, right? So you need you want probably some switch case. So some match case would work in combination with modulo, right? You know, modulo reminder operation, right? You just have to look it up, right? Right. So something plus, right? Plus what should computer do when it has a losing position, right? One idea, play randomly then, right? Right, right. Right, so this will be interesting idea, right? So this will be something for you to do. Okay, so now let's check. I think we are almost done, right? So let's do this. So we have a game, a move, right? And it will do all the savings, right? Computer level. For now, we only have a single computer level, right? So probably, right, to do this again later on, we want to also ask here again, right? Maybe you want to change levels here, right? So this would be something to add, right? So let's do this. Let's run it. So bit val computer. I'll do 2, right? That is the random, right? Okay, I'll do take 3. Computer took 1. Look at this. There's a difference now. So this, again, random is fun. Random fun, of course, is not very smart. So I'll take 3. It took 1 again. I'll take 3. It takes again 1. Is it? Did you make a mistake? Okay, no, it was not. Let's play another game, right? Yeah. Again. So 3. It took 3, right? It took 3. It took 2. It takes 2. Okay, so it's completely random. Great. 2 matches left. Well, now I am going to let computer lose. Okay, so great. Okay, my winning streak continues. Computer is doing pretty badly. Let's do one more. Oh, no, let's not do enough, but it works fine, right? Nope. And we are good. So, alright, so what did we do? Here in this part, we added a separate object, right? It's just a single instance of the class, so we only have singleton object, on which we're gonna use for calling the strategy, right? Again, it's possibly we want to also pass the game state. Maybe this might be better, right? And we could add the computer level to the name game, right? Again, it might not be relevant, right? The question is, do we want to store should this name game store the computer level, or is computer the computer state, right? That's one of the possibilities you could do, right? You could add the computer is player B, well, computer level, right? We could add it here as well, right? And use 0 as saying this is not a computer, right? So also you could add 2 computer, possibility of playing 2 computers versus each other. That's also fun, right? Okay, so let's move on to our exercise, right? This will be including so the exercise is as follows, right? So exercise as follows. You want to add support for new player names here, right? Maybe add an extra if, right? Even better, add a changing of computer level if possible, right? Time alone, right? If player B is computer, if player B is computer, right? So so that's one thing. And second thing is, of course, I want you to make this. So to do is figure out a smart strategy. Of course, that is using case. It's really using a reminder, right? So 2 things, simple things, right? And then we are pretty much done with our game, right? Add some game. Of course, you could keep polishing this. Of course, you could add a nice little graphical interface and things like this. But I think this is a good start for the application, right? So add support for new player games here, right? In our outer loop, right? And add get smart strategy. So fix this function basically to add more strategies, or to add fix this strategy. Fix me create strategy with smart strategy. Okay, So I think this should be kind of fun. All right, thank you all, and we'll continue then tonight.